So today we're doing lesson 4.32, the second to last lesson of module 4. And your learning goal today is to be able to interpret and evaluate numerical expressions. So what does it mean to interpret something? If you interpret a language or if you interpret some words, what are you doing? Tara?
It means like translate it.
It means translate it or make sense of it. Figure out what it means. And what does it mean to evaluate something? Junbak? Solve. So today we're learning or practicing how to interpret or make sense of, like understand and solve numerical expressions. That could be number sentences, it could be word problems, it could be words. Okay, so we're trying to figure out how to make sense of, understand, and solve numerical expressions. Order of operations is exactly what it sounds like. It's the order in which you do the operations. There's 4 operations in math. What are they? Addition, subtraction, multiplication, and division. They don't all, when you see a bunch of them together, there's a certain order you do things, as we know, right?
Yeah.
Okay, so what is you know how there's like a letter thing that we use to remember?
Yes.
PEMDAS, right? P-E-M-D-A-S. The P stands for parentheses, E stands for exponents, M stands for and division. Now, multiplication and division actually go together. It just depends on which one comes first. And then AS stands for addition and subtraction, and those two are also grouped together. Okay, so PEMDAS reminds us what order we need to do things in. So let's take a look at this first example. Go ahead and write it down. It says 12 divided by 3 plus 1. What operations do you see in this numerical expression? I see a division and an addition. So which one should we do first? Division, because according to PEMDAS, D comes before A. So should we do 12 divided by 3 first or 3 plus 1 first? Good. So in this one, we would do 12 divided by 3 first, which is 4. So this is the same thing as 4 plus 1, which is 5. So the answer to that question is 5. Now let's write this one down. It says 12 divided by, in parentheses, 3 plus 1. Do you see how it's the same operations? It's all the same numbers and all the same operations. They all have 12 divided by 3 plus 1. But the difference this time is there's parentheses. So according to PEMDAS, what part do we need to do first? So do we do 12 divided by 3 first or 3 plus 1 first?
3 plus 1.
So this is the same as 12 divided by 4, because 3 plus 1 is 4. Do you see that?
Yeah.
So what's 12 divided by 4?
3.
So here we can see in these two examples, they have the same exact numbers with the same exact operations. Do you see that? But 1 is equal to 5, and 1's value is 3. That's all because of order of operations. Do you see that? Great. Let's also review what we know about dividing decimals. 8 divided by 2 equals 4. 0.8 over 0.2. This is, how do I write this as a division sentence, by the way? Yeah, this is the same as 0.8 divided by 0.2. Okay. How can I make the divisor a whole number? What do I need to do? I need to multiply by 10 over 10. So I get 8 over 2, yes? So the answer is 4. Very good. What if I have 0.8 over 0.02? How can I make that divisor a whole number? What do I need to multiply by, Anushka? 100 over 100. So then, what's 8 tenths times 100? 80. And what's 2 hundredths times 100? So this is equal to 40. Very nice. Okay, we've been working with easy numbers. What if we have 23 and 84 hundredths over 0.2? Remember, I don't need to make everything a whole number. I only need to make the divisor a whole number. So what can I multiply by to make that divisor a whole number? Reagan?
10 over 10. No.
Okay.
Yes.
If I multiply by 10 over 10, what's my new whole?
238 and 4 tenths.
238 and 4 tenths. And then what's my denominator?
2.
Okay. Now, is it okay if my numerator has a decimal? How can I write this in standard form? Well, I would need to write 238 and 4 tenths divided by 2. Okay. How many times does 2 go into 200? 100 times. Good. So 100 times 2 is 200. I bring down the 3. How many times does 2 go into 30? Once. Okay. I have 1 left. Bring down the 8. How many times does 2 go into 18? 9. Okay, and I can subtract that, and I have 18, 0. And now I bring down the 4. How many times does 2 go into 4?
2.
2. So the answer is 1,192?
No.
Because over here, this was 4/10, so my n needs to be 2/10. Okay, so that's how you can solve that problem. So in your math notebook, copy down these words. Twice the sum of 3/5 and 1 1/2. Go ahead and just copy that word for word in word form. We're trying to find twice the sum of two numbers. When I see the word sum, what mathematical operation do I think of? Everyone? Addition. Good. Okay, so I'm trying to find something that's 2 times. Twice means 2 times. So twice the sum of 3/5 and 1 1/2. So if I do 3/5 plus 1 1/2, is that the sum of 3/5 and 1 1/2? Now I want 2 times of that, twice of the sum. Is that correct?
No.
Because according to my order of operations, if I wrote that, what would I need to do first? 2 times 3/5. Is that what I want? No, I want 2 times the entire sum of 3/5 and 1 1/2. So I need to put parentheses so that I show that first I'm finding the sum. When we're doing work with numerical expressions, we need to remember that the word sum means addition. Difference means what?
Subtraction.
Good. What word means multiplication?
Product.
Product. Good. And then what word means division? Good. Now, these aren't the only words, but this will get you off to a good start, okay? Because also words like twice, if you're finding twice of something, are you multiplying? Or half, what would you be doing? Dividing, right? If you're finding a third of something, what are you doing? Dividing. If you're finding less than of something, what are you doing? If you're finding more than of something, what are you doing? Okay, so it's important to know these words, okay? All right. Now that we found the number sentence, twice the sum of 3/5 and 1/2, 1 1/2, are we ready? Are we done?
No.
Because we also need to evaluate. Okay, so according to this, what do we need to do first? Multiply or add? Okay. Am I ready to add 3/5 plus 1 1/2?
No.
What do I need? I need a least common denominator. What would my least common denominator be?
10.
Okay, so 3/5 is equal to how many tenths? 6/10. And 1 1/2 is, and then 1 1/2 is equal to how many tenths? 1 and?
5.
Very good. So now I can add 6/10 plus 1 plus 5/10. So that equals 1 and 11/10, or 2 and 1/10. Now, I can rewrite this part as 2 times 1 1/10. Oh, sorry, 2 times 2 1/10, right? And am I ready to multiply?
No.
Why am I not ready to multiply right now? Alina?
Because you have to turn the mixed number into a least number.
Yeah, because right now I have a mixed number. So 2 and 1/10 is the same as how many tenths?
21
So this is the same as 2 times 21 tenths. Is there anything I can cross cancel? 2 and 10 are both divisible by 2. So I can change that to a 1, and the 10 becomes a? So this is equal to 21/5. Can I simplify that? What is that? 4 and 1/5. And because this is in fraction form, I can leave it in fraction form. Now it tells us to find half the sum of 3/5 and 1 1/2. Are we doing the half part first or the sum part first? The sum part. So that means we need to put that into parentheses. Again, we're finding the sum of 3/5 plus 1 1/2. And if we're finding half of something, is it 1/2 times that? Okay. So now let's go ahead and solve. Once again, we know our LCD is going to be 10. Let's talk about that in a second. We could do 6/10 plus 1 5/10, which as we know is 2 and 1/10, right? So we're finding 1/2 times 2 and 1/10, which is the same as 1/2 times 21/10. This time there's nothing we can cross cancel, so this is equal to 21 over 20, or 1 and 1/20. Now, Ben asked a really good question. He said, can we do divided by 2? Another way you could show this is the sum of 3/5 and 1 1/2 divided by 2. That works as well. Then what you could do is you would do 2 1/10, which is the sum, over 2, I guess. Or we know that when you divide by 2, it's the same as multiplying by what? When you divide by something, it's the same as multiplying by the reciprocal of the divisor, which would be 1/2. Is that the same thing as what we have here? Okay, so these two are actually equal. Okay? So in this case, we're taking a look at the part we're doing first, which is the parentheses. And so because in the parentheses we see that we're doing subtraction, we're finding the difference of 1/2 and 4/10. Now, are we only finding a fraction of that difference? Take a look at the next part, the 2/5 times. We're finding 2/5 of the difference, aren't we? So let's go ahead and add that. This part shows that we're finding 2/5 of the difference of 1/2 and 4/10. And therefore, right here, this is the word form of that expression. Finding 2/5 of the difference between 1/2 and 4/10. Do you see how we attacked this just the way we would solve it? We do the parentheses part first, we describe what's happening in words, and then we add on the beginning part. Does that make sense?